Hello everyone, welcome back to another video. In this video, we'll be solving the question has path. Now, if we look at the objective of the question, it says that, so it says that you are given a graph, a source, and a destination vertex, right? And you're required to find if a path exists between the source and the destination. If it does, print true, otherwise print false, right? So what does this mean? It means that, okay, let's first draw a graph to understand what it means. So let's suppose for input, we have a graph which is similar to what we saw in introduction to graphs, right? So just a basic graph over here goes to 4, goes to 5, and goes to 6, right? Let's suppose the input with this graph is a source which is 0 and a destination which is 6, right? So the question says that we have to determine whether there is a path. There is a path that exists from 0 to 6. What is a path? A path is a way in which you can reach 6, right? It's a route using which you can reach 6, right? So if we think about it, does there exist a path in this particular graph so that I can reach 6 if I start from 0, right? I think there is. So if we see, if I go from 0 to 1, then to 2, then 3, 4, and 5, and then I finally go from 5 to 6, I will reach to 6, right? I started from 0 and I ended at 6, right? Another path could be maybe 0, 1, 2, 3, 4, and if I directly go to 6, right? This also leads me to my destination, right? So there could be several paths, right? What we are interested in right now is to determine whether there exists a path at all, right? So what we are going to do, for this question is write a recursive solution, right? And to write a recursive solution, what we need is the faith and expectation, right? So what is our faith? Our faith is that if I would call from 0, let's suppose, I would say that all of my neighbors from 0, which are 1 and 3, they would tell me whether there is a path from 1 to 6 or 3 to 6, right? So if I'm at my current node, any node, right? Current node, what I would say is that from my current node, right? From my current node, I would ask all my neighbors, right? So let's suppose there are neighbor 1, neighbor 2, till, let's suppose, neighbor n. What I would ask from my neighbors is that does there exist a path such that you reach destination, right? From neighbor 1, does there exist a path such that you end up on the destination, right? If it says true, then if my neighbor says true that I can reach destination from so and so path, I would say that I can also reach, right? So I would also return true. That is because I can easily traverse from my current position to my neighbor. Of course, I have a direct edge to my neighbor, right? So if my neighbor has a path till destination, I would also have a path till destination, right? And this is the same for all the neighbors, right? From neighbor 1 till n. If any of the neighbor has a path, that is, if any of the neighbor says, okay, true, I have a path, then I would also say, okay, if my neighbor has a path, then surely I would also have a path, right? So in this case, what I can do is I will call from 0 and I would ask 1 and 3 whether there exists a path such that they reach 6 at some point, right? I hope it's clear. So if 1 says true, then I would say, okay, then I can also reach to 6, right? If 1 says, right, there is some path using which I can reach 6, 0 would say, yes, I can just attach myself in front of you and that would be my path till the destination, which is 6, right? So I would also return true from here, right? Or even if 3 says true, then also I would return true, right? If a single one of them says true, then my answer would be true, right? It doesn't matter if I get a true from 1 and then a false from 3. It won't matter. I would still say true. But what if I get false from both the sides? What if both of my neighbors say that they don't have any path till my destination? Then in that case, I won't have any path till my destination, right? So if I, let's suppose, erase this connection between 3 and 4. In this case, 1 and 3 both would say we tried, but we couldn't find a path till 6, right? In that case, my 0 would also say that, okay,